Welcome to Machine Learning for Beginners course. In this course, I will take you from a beginner to having a good understanding in machine learning. You don't need any prerequisite, you just need to be excited to learn machine learning. In this part 1 of the course, this is mainly focused on theory, examples, and little bit math. In part 2, we will look at the practical example with the code. So let's start the journey.
What is machine learning? Machine learning is the subfield of artificial intelligence. Its goal is to teach a computer how to perform a task without writing if and else statement. If you are not a programmer, think of it like a person has joined Tesla and he is a software engineer. He is programming Tesla's self-driving car. He is defining rules by writing if and else statement like this. If the road is bad, the car will drive slow. If the road is good, the car will drive fast. And if a car is front of this car very close, the car will brake and also horn. And he have to write so many rules, and this is a bad idea. At the same time, machine learning engineer joins Tesla. He will feed the data into machine learning algorithms, and gradually over time with experience the car will run these rules by itself and develop intelligence over time, similar to how human beings learn or any other living things learn on earth. There are 4 types of machine learning algorithms: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. What is supervised learning? This clip from the video, The Age of AI, How Far is Too Far video will help you understand this. Don't quit this video and go watch that video, because that video does not explain what is supervised learning. That video will be linked in the description. So let's begin. This man named Mark Sagar is the CEO of Soul Machines, and he has created a digital twin of his daughter.
Baby. Ooh. What can you see? So Baby X is a lifelike simulation of a toddler. Hey, are you excited to be here? She's actually seeing me through the web camera. She's listening through the microphone. Ooh. Yeah. Baby X is about exploring the nature of how would we build a digital consciousness if it's possible. We don't know if it's possible, but we're chipping away at that problem. Hey, baby. Hey.
What is supervised learning? As the name suggests, supervised learning means where a teacher or a supervisor is available. In this case, the man is teaching this child about what is apple, what is orange. So this man is a supervisor, a teacher, and this learning is called supervised learning. There are 3 steps in supervised learning. First, giving data collection, then training it, and then testing it. First, this man will give images to the computer by labeling it by name, that this image is apple, this image is spider. Second, he will train it to classify that this is apple or this is spider by using a method. And by using this method, the computer will be understand that if this shape and this color is there, then this is the apple, and if this shape like spider and the color is there, this is spider. And then this man is testing this by showing this to the computer and the kid by showing a spider object, and the kid has recognized that this is a spider and gets scared. If the kid does not recognize it, then this algorithm is not working. There are mainly 2 techniques used in supervised learning while training. First one you have already seen before, that is classification. When the man teaches the child what is an apple, what is a spider by showing an image, labeling it that this image is apple and this image is spider, and that is called classification. Second is regression, where mostly maths is used. For example, if this math teaches this kid how to do maths by teaching 5 plus 5 is equal to 10, 5 plus 2 is equal to 7. In this case, this man have to use regression. He have put the data into computer, 5 plus 5 is equal to 10, 5 plus 2 is equal to 7. And now by using this regression, the computer will predict what will be 5 plus 12, what will be 5 plus 8. And this is what regression is. They both are quite similar, but when you classify the image by label, that is called classification. But when you use mostly math, then you have to use regression. And classification and regression has multiple methods. Like classification have KNN, K nearest neighbor, neural networks, and regression has linear regression, polynomial regression, and more.
So what is semi-supervised learning? As we already know what is supervised learning, for example, when we are creating a model that can classify what is a spider and what is a cat, we use supervised learning here by labeling the data that this is a spider, this is a cat. But it requires a lot of manual work. So semi-supervised learning solves it. By using semi-supervised learning, you need little bit of labeled data and mostly unlabeled data. But everything is not good about semi-supervised learning. It has some cons. Number 1, it is more complex, so it requires more computational power. Number 2, if the quality of the data is bad, the result will be poor. So when to use semi-supervised learning? If getting the labeled data is hard and getting unlabeled data is easy, you should use semi-supervised learning. But when getting labeled data is easy, you should definitely use supervised learning cause the result will be more better using supervised learning. So you know that supervised learning is used when you are creating a model, like for example, you are creating a model that classify what is spider and what is cat. So you label data that this is spider, this is cat. Then you feed that to the algorithm and it learns by the label data that this is spider and this is cat. In unsupervised learning, you don't need to label the data. For example, you have bucket full of different fruits. For example, apple, mango, orange. So you don't have to label that this is apple, this is mango, this is orange. Unsupervised learning will find pattern like its size, its color, its shape, and it will predict that this is this and this is this. There are mainly 3 types of unsupervised learning algorithm. Number 1, clustering. Number 2, dimensionality reduction. Number 3, association learning rule. Let's look at one example of it. So the biggest example of it will be Amazon recommender system. The Amazon machine learning engineers don't label the data. They use unsupervised learning and feed the data, and the data will find patterns according to the things you buy. Let's look at its pros and cons. Number 1, no label data required. Number 2, great for pattern discovery. Let's look at the cons. Number 1, less control over what the algorithm learns. Number 2, it can discover patterns that don't always make sense. In this video, I will teach you what is reinforcement learning. So let's start this video. So let's start by looking at one example. You all have played GTA 5 and you all have driven the car in GTA 5. It is so much fun. Let's suppose you want to write a program that will drive a car for you automatically. If you use reinforcement learning here, the car will drive by its own and it will go to the wrong direction, sometimes right direction. So whenever it will go to the wrong direction and crash, we will give the car punishment. So the car will not repeat that mistake again. Whenever the car will drive good on the land, we will give the car the reward. So next time the car will drive the same, the correct direction. So the car is driving in GTA 5. So the GTA 5 is called the environment and the program which is running is called agent. It learns the same way like a boy learns to ride a bicycle. The boy will try to ride the bicycle, the boy will fall. So the boy got the punishment because he got hurt. So he will try to not repeat that again. The boy is able to ride the bicycle in the correct lane without following. So the boy gets reward, high dopamine. So the boy will try to ride correctly without falling. Another example is a robot, a humanoid robot. Let's say in your room, you have a humanoid robot. The goal of humanoid robot is to walk. So the humanoid robot here is the agent and your room is the environment. So the robot will try to walk and it will fall and sometime it will walk. So whenever it will fall, we will give him the punishment. So he will not try to repeat that again. Whenever he will walk correct, we will give him reward. So he will try to walk correctly again. So this was reinforcement learning. Hopefully you have understand it.
In this video, I will explain you what is linear regression with example and I will relate it with math. So let's begin. Regression is showing relationship between variables and on the basis of that do predictions. And linear regression is showing relationship between two variables, one dependent and second one is independent, and on the basis of that do predictions. If you don't know what a variable is, think of it like this. In your house you have a box. In that box you store your old stuff like toys. So that box is a variable and the toy is the value in this. So same like this is variable. So like you created a variable named age and in that you stored a value of your age that is 24. So whenever you call that variable age, you get the value 24. So that is variable. What is dependent and independent variable? So let's look at it for this example. So let's suppose you buy a new RTX 3090 and you are selling your old RTX 3060. So you are predicting the price on which you will sell your old 3060. So whenever you are predicting, so that variable is dependent variable. on the basis of hours you are predicting the price. So that on the basis of which you predict is independent variable. So linear regression equation is y is equal to mx plus b, where y is equal to dependent variable and x is equal to independent variable, where m is the slope of the line, which means per unit change in x, how much value will be changed in y. And b is the intercept, which means if the value of x is equal to 0, what will the value of y. So I will explain this with a project. So the project is predicting the price of vintage car. So we will do this in 4 steps, which is collecting data, second is calculation, and third is predicting the price, and fourth is visualizing it. So first we will collect the data for x year old, how much the price will be. So second we will do calculation. Just look here, age and price here. So age and price is the data we have collected. So x is independent variable and y is dependent variable. So here we have collected the data. First we will calculate the mean of x. So we will add this all, 8 plus 10 plus 12, and we will divide by how much the value is. 1, 2, 3 value is. So the mean is equal to 10. So we will same for the mean of y. We will add the value of y here, price which is, and then we will divide it by 3. So the value is 13. So now we have to calculate deviation. So deviation we have to do is that first we will calculate deviation of x. So we will minus 8 minus 10, which is equal to minus 2, 10 minus 13 is equal to 2, and 0 means, and 12 minus 16 is equal to 2. And same we will do with deviation y, which is 10 minus 13 is equal to minus 3, and so on. 13 minus 13 is equal to 0, 60 minus 13 is equal to 3. And now we will do product of deviations. So we will multiply this x and deviation x and deviation y, which is we will multiply it here like this, all three, and the value we get here is minus minus plus 6, 0, 6. And we will do next sum of product of deviation. So we will plus it all. So the value we get is 12. Next we will do square of deviation for x. So here what we will do is we will square x. So deviation x. So minus 2 minus 2 in square is equal, minus 2 square is equal to 4 because it is in plus, and 0 square is equal to 0 here, and 2 square is equal to 4. So here we have done this much stuff. So now here is our equation, y is equal to m x plus b. So here we have our y already, and m also here we have already, m not x we have already, and we have to calculate m and b. So here you can see that y and x is there. Okay, y is here, our x is here. Okay, now we will calculate m and b. So in order to calculate m, this is the formula, sum of product of deviations divided by sum of square of deviation for x. So here we will do here m. So what is the sum of product of deviation? Let's look. Sum of product of deviation is equal to 12 divided by 8, which is sum of product of square of deviation. So we will plus it all here. So which is the value our 8. So we will divide it. So when we divide it, what value we get? We get 1.5. Okay. Now we have done here. Now we will calculate b. B is equal to mean of y and m minus m into mean of x. So what is mean of y? Let's show you here. So mean of y. So this is mean of y, which is 13, and m is our this. We have 1.5, which we have calculated here. You can see here 1.5 is our, and we have to mean of x. We have to multiply it with mean of x, which is 10. So let's do it. Sorry for writing like this, but I am not used to use graphic tablets. So here is 13 minus 1.5 in bracket into 10. 13 minus 5, 15 is equal to minus 2. So here we have done, we have find a B, and now we will visualize it. So let's visualize it. So now we have get the B. So this means that we will visualize it now. So I have visualized it. You can see this here. So x is equal to 0. When x is equal to 0, y is equal to minus 2. So I have visualized it by positive regression. And here you have the price we have gotten and age we have gotten. I have showed it here. So x is equal to 8 and y is equal to 10. So here is 8 and y is equal to 10, which you can see this. And same for x is equal to 10, then y is equal to 12, which is the price, independent and dependent variable. And now when somebody give you that calculate this, predict this, if the age is 40 years old and now you predict the price. So you can easily do that because you have m, which is 1.5, and now you have getted this, now you have gotten this x, which is 40. So and you have also b, so you can do minus 2, and now we can multiply it. This is 60 minus 2. Now we have got $58. In this video, I will explain you what is logistic regression with examples. So let's start this video. So logistic regression is used in supervised learning, and in supervised learning used in classification. So what is classification? Classification means putting something in a category. For example, you bought a new car and you are putting it in a category of new or old. So you will put it in a category of new. So that is classification. So here is another example. You are predicting car is new or old. So here is car age, which is independent variable, and here is dependent variable, which is new or old. So 1, 2, 3, 4, 5, 6, 7, 8, this is continuous data, and 0, 1, this is categorical data. 0, 1 is binary, which also can means yes or no. 0 means new, 1 means old. So the difference between independent and dependent variable is that dependent variable is the variable which we predict the value, and independent variable is the variable on the basis of that we predict the value of dependent variable. So the difference between linear regression and logistic regression is that in linear regression there is both continuous data, independent and independent variable, whereas in logistic regression independent variable is our continuous data, and whereas dependent variable is our categorical data. We can have multiple independent variable, but we can have only one independent variable, which means yes or no, old or new, for example. This is the equation of logistic regression. Y is equal to 1 divided by 1 plus e minus power a naught plus a1 x, where y is the dependent variable and a naught is equal to interception, which means what is the value of y if the value of x is equal to 0. And we show the interception in a graph like this. And a1 means how much y changes per unit change in x. If we decrement x, how much y changes. If we increment in x, how much y changes per unit change in it. And also y is the independent variable on which we do prediction, and x is the independent variable. And we show it like this in a graph. Here we have independent variable, which is car age, which is our x, and here we have y, which is our dependent variable, which is car is old or new. So here we don't show it like linear regression, like in continuous data, because this is not a continuous data. This is categorical data. Either it will be between 0 to 1. So here we can do half, like here 0.5, and we divide it here. Up here it will be old, and from down here it will be new. So this value is here 0, which means new, and this value here, which means old. And if somebody asks you, my car age is 5 years, what predict it is a new or old? So you directly don't do it in your mind. You will use this formula to do it. Okay, and the data could be bigger, but for example we are keeping here it's simple. So you will use simply this formula, and you also think what will the value of, how we will calculate the value of a node and a1. And this is the long process in itself, and it will take some time. So I will make a new video about it. But in exams and most of the place where you get this question, there is a node is already defined and a1 is already defined. So for example, A node is minus 1.5 and A1 is 0.6. How you will calculate this? And you have X which age is 5 years. So you will use this formula. So this is the formula you will use. At A node you will put 1.5 here. This is 1.5. 0.6 we have here value. So we will put it at 0 at A1 here. So here it is. And we will multiply it the value we have, which is 5, which we have given. So we get 1.5. So here we get 1.5 here. So what we will do it, we will 1 divide by 1 plus E minus power 1.5. So we get 0.818, which is 82%. So we can put this here, 818, 82 here, 82% will go here. So this means that this is an old card. So this is classification. We classify this, either this belong in this category, either this belong in this category. For example, in our category, this is the new one and this is the old one. Hello everyone, in this video I will explain you the difference between logistic regression and linear regression. So let's start this video. So both logistic regression and linear regression are used in supervised learning. But the difference here is that linear regression is supervised regression model and logistic regression is supervised classification model. So what does that mean? So linear regression will predict in continuous data. So what does that mean? For example, you are selling your old RTS 3060. So you are predicting in how much price you will sell that on the basis of hours used. So you are predicting in hours. So that is continuous data, that is in number. So we use linear regression in where mathematical data is used. So we are predicting in something like that. The price could be anything, like we are selling it in $240. But here in logistic regression, we are predicting in categorical data. For example, here is you have a car that is 2-year-old and you are predicting that it is old or new. So yes or no, 0 or 1. This categorical data, yes or no, 0 or 1, binary. Okay. So the equation of linear regression is this. Here, y is equal to a0 plus a1 x1. So where y is dependent variable and x is independent variable. Y is the variable which we are predicting on the basis of x, which is independent variable. So where a0 is the intersection of the line, which means if x value is equal to 0, what will be the value of y? What will the value of, so here not this thing, x is equal to 0, what will be the value of y? And we show it in a graph like this, okay? Whereas y is also here dependent variable and 1 plus e power minus a0 a0 plus a1 x which is independent variable. So the difference here is that by using this equation in linear regression, we get data in continuous data. For example, that RTX card example which we were selling, RTX card, so graphic card, so that we are getting $240 in result value. So but here what we get is, by using this equation, we get the value between 0 to 1. It could be near to 0, 0.2, or it could be near to 1, 0.8. Okay, so yes or no, also in binary. So that is categorical data. Hello people, in this video I will explain you KNN classification with real example and mathematics behind it. So let's start this video. So KNN stand for K nearest neighbors, okay? This is the full form of KNN, and KNN is a classification algorithm. At the time you are watching this video, you may know that what is classification. If you don't know, classification is predicting in categorical data, which means deciding a category of something, this or that, old or new. For example, if I give you a phone and ask it is Android or iOS, so you are deciding which category this is based on your phone model. The answer could be anything, old or new. You are deciding a category of something, okay? And whereas regression is used for predicting the value, for example, predicting the price of the phone. So the price of the phone could be anything which we can predict. So it could be $240. So this is a value, this is a continuous data. In regression we predict in these numbers, okay? Whereas in classification we predict in categorical data, old or new. Okay, like this, any category. We decide the category, okay? Hopefully you have understand it till now. So what is KNN then? KNN is a Hello World program for classification, okay? Here. So when learning classification, you should start with KNN because KNN is the easiest and simple algorithm to start with in classification, but it is very important. So let's define K nearest neighbors, okay? Let's suppose I am thinking should I buy a new PC or not. So for this I have taken voting from my close peoples, nearest neighbors, okay? That is nearest neighbors. So on the basis of that I am deciding should I buy a new PC or not. So this is classification on the basis of nearest neighbors, okay? So we have to now calculate distance and on the basis of that we will know who is nearest. So here is the example, you will understand by this example. So example predicting movie genre. This is from IMDb rating. This is the IMDb rating, duration and genre of the movies. And this is the upcoming movie of 2024. By the time you are watching this video, this movie has already came. Okay. So here I have IMDb rating. This I have guessed. You can put real data here, no problem. This is duration, which also I have guessed, but it is genre and real movie name, which I have put in here. And this is movie can be comedy and adventure also, but I have put it here to make it more simple. So first step is to collect data. This is the first step. So I have collected this data here, okay? And this is small data. On the real world, we use big data, okay? But when you understand this in small data, you can understand this in the big data also. Step 2, we will train our model on the data we have collected, okay? This is step 2. And step 3, now we will predict genre of Sonic the Hedgehog movie with IMDb rating 7.4 and duration 114 minutes, okay? Based on collected data. So Sonic the Hedgehog movie is also coming in 2024. So we have a fake IMDb rating and duration, which could be real, no problem. And now we will, on the basis of that, we will decide which genre this belong. And on the basis of our collected data, which is here, this is our data which we have collected and trained the model on the basis of that. Step 4, we will calculate distance. Now we will use mathematics. Without mathematics, you cannot understand this thing, okay? What's going behind this whole thing, okay? So step 4, calculate distance. Calculate the Euclidean distance between the new movie and each movie in the data set. So what is Euclidean distance? So what is Euclidean method? Euclidean method is used to find straight line distance between two things. So for example, here we will have this line like this, x-axis and y-axis, okay? And now we will find straight line distance. So maybe we will have a straight line here like P and here a line Q. Sorry for my handwriting, not the best, okay? So here we will have a correspond value which is x1 and here we will have a correspond value which will be y1 and here we will also have a correspond value which is x2 and here also we will have a correspond value which is y2, okay? And now we will calculate distance between these two things, PQ. How we will calculate this? By using Euclidean method, okay? Here we use Euclidean method. So now here we have P corresponding which value will be x1 and y1, okay? And here we have Q corresponding which value will be x2 and y1, okay? So how we will calculate Euclidean distance? This is simple. x1 minus x2 here and this whole square plus y2 minus y1 whole square, okay? And this will be a square root, okay? This all will be a square root, okay? And here we have distance of P and Q. This is the distance of P and Q. So this is how we find straight line distance between two things, okay? So now we will use that method here, okay? We will use that method here. So how we will use that method? So here we have that data, collected data. So the Hedgehog movie with IMDb rating, here you can see the Hedgehog movie with IMDb rating of 7.4 and duration 114 minutes. Okay, so here our X1 will be 7.4 and Y1 will be 114. So that method we will use here. So this is X2 and this is Y2. So we will calculate Euclidean distance between our data which we have of our movie, which is IMDb rating and minutes, okay, of the movie here, Deadpool and Wolverine, okay, and this is data from Hedgehog movie which will be calculate. So here we have 7.4 and minus 8.0 and minus 114 minus 116 square root and minus this value we will get, which is 46. Okay, like this we will do for every movie here. And second movie, which was our Kingdom of the Planet of Apes, this movie is there. So we will put here 7.4, this data of Sonic Hedgehog, and this X2 6.2 and here whole squared, and again we will do and we will get this 56. Okay, now we will, after doing this 4, we will come to step 5, and that is select k nearest neighbor. So how we will select k nearest neighbor? So first let's select one k nearest neighbors. Okay, k is equal to 1. So who is nearest k nearest neighbor you have to find. From this much values you have to find which is nearest one, which is close one, means which is the least values of all among this. So which is nearest one, which is the least value among this. This is clearly 41. So 41. So let's check movie in 41. Which is movie is there? This one, distance 8.2 and 155 minutes. So the Garfield movie, which is comedy movie. So Sonic the Hedgehog is a comedy movie which we have predicted by using one k nearest neighbors. In real world we have to use more k nearest neighbors. For example, we should use up to 5 nearest k neighbors. Okay. For example, here we have used small data, but in big world we have much big data. Real world we have much big data. Okay. So for example, there will be a lot of data here, and then we will select from that 5. Okay, and on the basis of that we will predict it. So here we can select, let's select 3 data because we cannot select 5. K nearest 5 1. Okay, so k is equal to 3, and which is nearest one? 41 is the smallest, and after that 46 is the smallest, and that 54 is the smallest. This is the data k nearest neighbors our. And we will do majority voting. So most of we have 2 comedy and 1 action. So majority voting goes to comedy. So our movie is Sonic the Hedgehog is a comedy movie. So we have predicted the movie. So hopefully you have understand this. Hello everyone, in this video I will explain you naive-based classification with example and mathematics. So let's start this video. So naive-based is the method used in supervised learning for classification. So what is classification then? Classification is used to predicting in categorical data. Example, predicting the category of a car. Is it old or new? Naive-Bayes is based on Bayes theorem. Here probability has a very big role because Bayes theorem is based on probability. In naive-Bayes, Bayes is Bayes theorem, and naive means all the variables we are using here is independent in each other. Hopefully you are understanding this. In order to understand naive-based classification, you first need to understand Bayes theorem. So let's see what is Bayes theorem. I will show you with example. Okay. There is a Tesla showroom. Okay. That sell Tesla cars. This is the showroom. Okay. And that showroom has 3 Model Y. Okay. Model Y. And 5 Model 3. Okay, so you buy a car from there. So what the probability of you having Model Y? So you can easily do that because we are talking about Model Y, probability of Model Y. So we can do 3 and by total here, which will be 8. So we have 3 by 8 probability of having Model Y. Okay. So another example of it will be this. Here you can see that here, sorry. So here we have 2 showrooms, showroom 1, showroom 2. So showroom 1 have 2 Model Y and 5 Model 3, and showroom 2 has 5 Model Y and 2 Model X. Model 3, sorry, Model 3 it will be here. Model 3, okay. Model 3. So what is the probability of you buying Model Y from this showroom, any of the showroom? So we can easily calculate this. First, we will need to find the probability of this showroom, that what is the probability of buying from this showroom is to 1 by 2. Okay, and here this showroom also 1 by 2 probability of buying from this showroom, and buying the model Y from this showroom 1 is the probability of 2 by 7, and buying model Y from this showroom 2, the probability is 5 by 7. Okay, now we can easily find the probability of buying model Y from these showrooms. So that will be easily 1 by 2 multiplied by 2 by 7 plus 1 by 2 multiply 5 by 7. So you can easily do this value and you will get the probability value, the probability of model Y. What will be the probability of buying model Y? This maths which you have seen today, this is not Bayes theorem, but this will help you understand Bayes theorem. So now we will look at Bayes theorem. This example will help you understand Bayes theorem. Now you are buying a Tesla and that Tesla model is already given. You are not predicting the probability. Okay, that is given that you are buying Tesla model Y, and that is given that you are buying Tesla model Y, but you have to find the probability that you are buying from showroom 1. So we have to find the probability of that we are buying from showroom 1. So this is the formula to find probability of that. This is Bayes theorem. Okay, so here this is X. So what is this X? So this X is an independent variable. Okay, and this is the value which this is model Y, and this is showroom 1. We have to find that this model Y is from showroom 1. We have to show that. So how we will show that? X divided by Y. So here X is model Y and Y is showroom 1. Okay, and here Y is showroom 1. So here we will give this, we have to give the probability of X by Y, so which is model Y and showroom 1, so which we have already, that is here probability. We have to give the probability is 2 by 7 here. Okay, the probability is here 2 by 7, which we have to give the probability of showroom 1 of model Y. So here we will write 2 by 7 into PY. So Y we have to give Y is showroom 1, which is 1 by 2. Okay, that we have to give here 1 by 2 divided by probability of X. So what is probability of model Y? Total probability we have to give here, which is this. We have to calculate this and then we have to put it here, total number here, and then we will calculate this and then we will get the probability that this is from showroom 1. Okay, hopefully you are understanding right now. In real world we do it like this. We don't have one variable like this, independent variable, like here you can see that independent variable, that in model Y. In real world we have multiple independent variables that are independent in each other, like x1, x2, xn. Okay, here, and this is our Y. So if we are predicting like this, if the car is new or not, yes or no. So if we are predicting like this, yes, so here we will predict the value that this is yes or no according to this factor. So like this, here we have put in X divided by Y. So for every factor like this independent variable, we will put here x1 divided by Y, x2 divided by Y, x3 divided by Y. Okay, and now here into Py, which is Y is our yes. Okay, probability Y, which is yes, and here is the probability, like I have shown here. The total probability here goes with that. You have to do it here x1, x2, x3. Okay, and here you will do it for no, that car is not new. You will do it for no, that car is not new. Okay, so that car is not new. Okay, no, so you will check the probability that that car is not new. Okay, by according to these factors, independent variables. Okay, you will do it same here, and this thing is same. You can see this thing is same. So we don't have to write always this. We can just look at this because this is the main result, and we have to divide by same for dash 2. Okay, so by doing this we get the percentage that if the percentage that the car is new is 80% for example, okay, and no percentage is 20%. So we will look that which percentage is higher. If no percent is higher, for example, it will be 80 and this will be 20, then this will be no will be the answer. But here yes, for example, yes is 80%, so that means yes is right. So that we have to do it here. You have to find that which has highest percentage, and according to that predict that it is yes or no. Okay, so this is Bayes theorem, and this is how naive-Bayes classification work. Okay, so now I will show you the example of it. So now here is the example. Okay, so this is the data which we have. This is x1 and this is x2. Both are independent variable. This is which we have to predict yes or no. Okay, this we have to predict based on this data. So this is the data of patients, multiple data, which means that if this person have COVID and do not have flu, that means this person has fever, like this data. Okay, because we have multiple data, we are just not looking at 1% data, because it does not mean that one person has COVID and he has fever, so another person come and he have COVID will be have fever. We have multiple data. So how we will use this data and calculate? Let's see here. So now we have this data of patients. According to this data, we have to predict that they have fever or not. So where we will predict? So here we get a person data. This is a person data which have flu and COVID. So first we will check that this person has fever or not. So we will check that this person has fever or not, and we will get the percentage here according to like this, which we have done before. That formula you have seen, this formula according to that we will do it. And second we will do according to this formula, that is this. We will check that if this person don't have a flu, don't have fever or not, and we will do like that from that formula. Okay, and which percent will be higher, that will be right. For example, if there it will be 10%, 20%, and this will be 10%. So this will be he has fever. Okay, we are predicting like that. So here when we are looking at yes, so here we have flu and COVID, and flu, P is flu and yes, okay, into P, and COVID is equal to yes into PS divided by flu and COVID. And here also divided by divided by flu and COVID, but we are not using here because we have to divide by same, because here will be also flu and COVID same value divided by, and here also same value flu and COVID divided by, and this is for no. So here x1 x2, so here it is yes and x1 x2, which is our flu, yes, flu and COVID. Okay, so x1 flu COVID is equal to yes and into P, and flu is equal to yes, and we are divided by yes, P is equal to yes. And here we are not dividing by this value, dividing because this and this value of no, that is same, that's why we are not dividing. And from here no, we have to do no and COVID flu. So COVID no, flu no, and here divided by no. Okay, and that's how we get the highest percentage here, 80 or 20, whatever. And then we will select which one has the highest percentage, and that we will select, and we will get the predicted data. Okay, so step 1, first we will take out prior probability. That is, first we will check that fever probability is equal to yes, how much. So we will take that from total data. To total data is here how much is yes of fever. Okay, 1 2 3 4 5 6 7 8 7. Okay, so here 7 and total value 10. Okay, and fever no, so fever no 1 2 3. Okay, 3 by total 10. We are taking this prior probability here. Step 2, condition probability. So here we will check that for COVID yes and fever yes, how much is there. So COVID yes 1, fever yes 2 here, 3 here, 4 here. Okay, so we have total 4, COVID 4, and total yes of fever how much we have, that we have already calculated here, 7, 1 2 3 4 5 6 7. Okay, here, and flu yes and COVID yes, how much, 1 here, 1 2 3. Okay, 3 by 7, that we have done over here, that we have gotten here 7 of how much time fever is there. Okay, so here we will do same thing for no, that is COVID no, and flu no. So we will check how much that is. 1, 2, where is 2? Here, and total we will get that 2 by 3. Okay, total no is here, fever no is 3. Okay, and for flu we will check that same, no flu and no fever. Okay, so no flu and no fever 1, 2, and total we have gotten this 3. Total 2, we have gotten 2, and here fever how much time we have gotten? No, 3. Okay, so first we will check this so we can and get the value, so we can directly put this in this formula and we can get our result easily. So what we have to do is here, so here flu is yes and fever is yes, so here it is fever. Okay, so what we will do here is we will check for flu yes, 3 by 7. So now here we will put 3 by 7 into COVID yes, fever yes, so that is 4 by 7 here. So here we will put 4 by 7 into probability of yes. So probability of yes is here 7 by 10, which we have already calculated. That's why it is now easy for us to put that values 7 by 10. And now we can cut this, and 4 minus 4 to 12 and 70, 635 is equal to 0.17. So we have now 0.17. Now we will do it for flu no and fever no. Okay, so here we will do it, which is our value 2 by 3. Okay, flu 2 by 3, and COVID also here, which is no and fever no. Okay, so we will do it 2 by 3 into 2 by 3 multiply by probability of no. So probability of no is equal to 3 by 10. So which we will put here. Okay, let's put 3 by 10. So this cut. Okay, so now we have 4 into 30, 12 by 15, 0.13. So now if a patient come to you with flu and COVID, so what will be the probability of him having fever? So the probability of him having fever will be yes, because 17 is more than 13. Okay, 0.17 is more than 0.13. So that's why we will predict that this is yes. Okay, hopefully you have understand it.
If you want me to make a video according to your request or answers to your questions, you should click on the top link in the description. That will take you to my school community, which is made for people who love machine learning. By doing so, you will get exclusive videos there, videos according to your request. If you have any request on video, I will make the video for you. I will answer all your questions. By doing so, you will support me on this channel, because this is my only full-time job and I am not doing anything else. Thank you.
In this video, I will explain you what is decision tree. So let's start this video. So decision tree is also called decision tree classification. Decision tree can be used for both regression and classification, but it is mainly used for classification. So what is classification? Classification is used for predicting in categorical data. Example, predicting the category of a car. Is it old or is it new? So we are predicting the category. Maybe it will be old, maybe it will be old new. Okay. So where is decision tree used? Okay. So I am making a decision, should I buy a new PC or not? So I am making a decision, should I buy or not? So we use decision tree here to help us take a decision. Okay. So how does decision tree work? So let me show you. And how does it look? So here we will create an attribute. So okay, so let's create an attribute. And this is called PC status. Okay. And what is this? This is the root node. This is the node from where everything is connected. Root node. Okay. Root node. Okay. This is called root node. And we will connect edges from here. Okay. This is edges. And here we will check if the person have PC. If the person have PC, the decision will be no, he should not buy a PC. Okay. And here we will check not have PC. So if he does not have PC, so we will create a new node, a new attribute, that is money. If he has money or not. And then if he has a money, we will check if he has enough money or not. Okay. If he has enough money, he should buy a PC. And if he does not have enough money, he should not buy a PC. So this is what a decision tree is. It helps us to classify should I buy a PC or not. Okay, it helps us to classify. And here we can further connect more edges here. Okay, we can connect more edges like this here. Okay, like here we can connect more edges. Like here, if we have PC instead of no, then we can do here more edges, and we can do old PC or new PC. If he has old PC, he should buy a PC. If he has new PC, he should not buy a PC. Okay. For example, we should not directly select a root node directly by our own thinking. Okay. We have to use mathematics to calculate that. So how we calculate? We use splitting to select root node and further divide it like this. Okay. This is root node and we further divide it by edges. It is based on entropy and information gate. Splitting means choosing. First we calculate entropy of data set, then we calculate information gain. Okay, entropy and information gain is based on data purity. So what is data purity means? It means that the label data which we have collected, how nice it is defined. If the data is not pure, we get less information gain. If the data is pure, we get more information gain. First we will choose the root attribute. We will choose this root attribute by all of the attribute we have in our label data. In our label data we have multiple attribute. Okay, by looking at whose information gain is the highest. We have calculated the information gain, but whose information gain is the highest, and we will make it root attribute. That will be the root attribute, and on the basis of that we will further divide it. So we use mathematics to do that. Okay, so what is pruning? Let's suppose we have multiple edges. For example, like this, here something like this. Okay, and now it became messy. Okay, so by using the pruning, we remove unwanted edges. Okay, so we use splitting to choose root node on the basis of entropy and information gain, and we calculate that by using mathematics. So in the next video I will explain you the mathematics behind it. This was just the introduction. Thanks for watching the video. In this video, I will teach you how to draw a decision tree step by step with mathematics and how to arrive at a decision. So let's start this video. So we use decision tree for both classification and regression, but it is mainly used for classification. So what is regression? We use regression to predicting in continuous data, which means mathematical data. Example, predicting the price of old PC. Maybe it will be $1,000, $2,000 or any number, but it is used in predicting in mathematical data. Any number it could be. And what is classification? Classification is used in predicting in categorical data. Example, predicting if this card is new or not, yes or not. This is categorical data. We are deciding which category this card goes. So what is decision tree? Decision tree helps us to decide the category when we use it with classification. Example, should I buy a new PC or no? Yes or no. It helps us to decide that. Okay. So let's draw our decision tree which will help us to predict should we buy a new PC or not. Okay. So first we will create here a root node. So we will call it PC status. So this is called root node. We draw it by like this, drawing a circle like this or rectangular, either one of the way. Okay. This is called root node. This is the node from which everything is connected. Okay. Root node. And here will be edges will be gone here like this, like this, and like this. Okay. So here it will be on PC status if the person has already on the PC, or if he has not on. Okay. Not on, or he has rented the PC. Okay. So if he not on, we can come to a decision that he should buy a PC. Okay. This is the leaf node. This is the decision. And if he own the PC, we will make a new node here. So here will be another node that will be called model. If he own the PC, which model he owns. Okay, we draw it like this. Now we will check it which model it is. Latest or old. If the model is latest, he should not buy a PC. Okay, no, decision should be no. If the model is old, he should buy the PC. So this is the decision. This is what a decision tree. And here we can do for rented. And we can go all in like this and create more edges and nodes like this. The thing is here that we don't directly, for example, choose the root node like this. This will be root node. This will be here edges. This will be here another node. We have to, there will be multiple attributes like here model and here PC status. This is another node. and we have to calculate this to know which will be root node and which will be here node and which will be edges here and which will be edges here. Okay, so we calculate this with the help of entropy and information gain. We do this by ID3 algorithm. We can do this by 3 algorithm: ID3 algorithm, random forest one, and cart one. The most popular one are random forest and ID3 algorithm. In this video we are looking at ID3 algorithm. In next video we will do random forest one. Okay, random forest is combining multiple decision trees. Okay, so first we need a data set to train our classification model decision tree so that we can draw that later. Okay, so this is the data set. Here we have person name and their PC status and the person age and their model budget, and on the basis of that data we are predicting that this should he buy a PC or not. So this is the data. For example, Virat own a PC. He is 36 years old. He have a latest model of the PC and his budget is high. Should he buy a new PC or not? No. But like this, many of the data is available. This is attributes. These are all attributes. On the basis of these attributes, they are predicting should we buy a PC or not? Yes or no. This is decision. Okay. So now if somebody come to us and say he does not own a PC and his budget is high, should he buy a PC or not? So what we have to do to predict that, we have to calculate entropy and information gain first for each data set, and then we can draw a decision tree. So there is only two steps to create decision tree. First is to calculate entropy and then calculate information gain, and we have to do this multiple time for each data set, and on the basis of that we can create decision tree. Okay, so this is how we calculate entropy and information gain. First step is to calculate entropy of entire data set. So this is the data set which I have already shown you. So first we have to calculate entropy of this. So how we calculate entropy of this? So this S symbol is entropy symbol, and this plus and 9 and minus 5, this is yes or no in that data set, and 5 is no. Okay, plus is yes and minus is no. I have shown it to represent you all. So I have represented by plus and this is by minus. Okay, so here we can see we have to write how many yes are in the data set and how many entire data set and how many no are on the entire data set. So here is our entire data set. We have total 9 yes and 5 no. Okay, so that we have done here 9, and this is 9. First here we will write this 9 which is yes, and our total data set which is total yes or no. Okay, which is 14, and log to 9 by 14 minus here this is no, 5 no, this one no, and which is entire data set log 2, and we get 0.94, which I have already done. You can do it by calculator. Okay, and second we have to do is at step 2 entropy of all attributes, entropy of all the values which we have in the data set, these values. So first we are calculating the data set of PC status. So this is PC status. This first entropy we are calculating of this. Okay, we are calculating this for this PC. Second we will do for this, third we will do for this, and fourth we have to calculate for each of the following. Okay, so here we are doing for PC status. You can see this is for PC status. So this is all the value: entropy of own, entropy of not own, entropy of rented. Okay, so here is own, not own, rented. Okay, so in own there is 2 yes and 3 no's. Okay, here you can see that in on 1, 2 and 3 no. Here you can see this, there is 3 no and 2 yes. Okay, and we have done that to again. Here is the yes data set here, and here is total data set, and we have done like this. We have done here. Okay, and this is a minus 1 no, which is no. Okay, and this is yes, and we have done it here, and we have done same for this. We have done same for this, and now here add information gain. Now we will calculate, this is what we were calculating entropy of here of the all the value of attributes which is status. Okay, and now here we will calculate information gain of from that entropy. So first we will write here entropy of whole data. So entropy of whole data is 0.94. Okay, so here will be 0.94 here. Okay, minus 5 by 14. So 5 by 14, this what we will do is, so we will plus this yes or no, total yes or no. Okay, 5 and total data set yes or no, that is 14, and multiply by entropy of own. Multiply this entropy of own minus in this entire yes or no 4 and entire data set 14 and multiply by entropy of entropy of not on this, and we will done same thing for this 5 by 5 which is total yes or no for this, and and this is 14 for the total data set which is here 14, and we have multiplied with this entropy of rented, this is this, and we get the value this, and we will do same for the thing for every attribute here. We have done first for PC status here, and we will do same thing for this percentage, model, budget, these 3 things we will do also. Same process again. Let me show you and go a little bit faster. So this is for percentage, we have done same thing again here. This will be the same because this is entire data set, and here it is entropy of 36 which is a entropy of 24 40, and here is the same formula. So we have done this for percentage, and again we will do for model which is their model. We have done same for entire data set here, and we have gotten this value, and now same thing for budget. So where we have done for that for budget, hopefully you are understanding till now. It is easy, not that hard to understand. And we have gotten this. So now this is the total information gain we have gotten from PC status attribute, percentage attribute, model, and budget attribute. So why we are calculating this? So we are calculating this so that we can select which will be the root node across these attributes that we have. This is all the attributes: PC status, percentage, model, budget. This is all the attributes, and this is the value inside that. So this will we are calculating which one will be the root node by getting the information gain which we have gotten here. This is the information gain which I have gotten. The which one will be highest, that will be the root node. So which is the highest here? The highest one is PC status 0.246. So this will be our root node. So let me create a root node. So here it will be PC status. This is root node. And now which will be the edges inside it? So let me see, 3 edges was there. You can see this here. On, not on, and intent. 3 values is there. For example, if this was here, model was the root node, we will see latest and old. All the values which are here, we will put it in edges. But here it is PC status, so we will put on, not on, and rented. So here it will be on, not on, rented. So in not on, we can, if the PC status is not on, we can see here not on, and not on all the values are yes. Not on, yes, 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 yes. Every decision of this is yes, we will select it yes. We can calculate it from here yes. Because every decision it have is yes. Not on has every decision which is yes. So we will do yes. Because here we have every decision of not on yes. So here we have not on yes, yes. And where is not on more? Not on yes and not on yes. That's why we are selecting yes. If it has no and yes, we will not select it. And on, we cannot do here not yes only, because it has both value, yes or no. You can see it here. On, no. And here we will go down, no. And when we go here, yes, it has both value, decision, and same for the rented one. So we have to calculate again for the data set of these two. So we have calculated for the PC status. Now we will calculate for on. We have already done not on. So we will not calculate this. And now we will do for it for rented too. So we will calculate entropy and find out information gain for this data set on and rented. Now we will separate on and rented from here because we don't need not on. That's why. So here is the data after, and we will get yes and no for that only, on and not on, and not for the on and rented, not for the not on. Yes or no for that. So here this is the value. So this is the data here. We have separated this data here. So this is the person name and this is the PC status. We want to calculate for on. So this is the age. So first we will calculate. We have already on here as selected there. And now we will select which one will be the node. So we will calculate again entropy and information gain for percentage, model and budget. Okay, so let's do it again. So here we have done it again. Entropy of own. So this time there is not entropy of entire data set. This time it will be entropy of own, because we are calculating this for own, which will be the node for inside own. Okay, so this is total yes and no in the own. Okay, this is yes, 2 yes and 3 no. Okay, here is 2 yes, okay, in own, 2 yes and 3 no. Okay, that is here, and we have done it again. Now we are doing this for here, we are doing this for percentage. Okay, so we will, inside percentage there is values 36, 24 and 40 here. Okay, so we will calculate entropy of all that value. So this 36 value has 0 yes and -2 no, plus 1 yes and -1 no. So we have calculated that from here, and here is information gain, and here is the total value of yes or no in the data set, which is here, and into entropy of 36, this is here, and we have done it again and get this value. And now we will do it again for this time model, and for model we have done it again. So this is the value which we have gotten, and again we will do it for budget 3 times this again, and we will have gotten this value 0.19. Doing the same process again. It is simple, you have to do it same thing again and again. Okay, so now we have arrived at this here, total information gain of every attribute here. So now we have already know which will be our root node, that is PC status. This is the root node. Okay, and here we have 3 values. Okay, and we have first here which we have not own. If not own is there, if somebody says should I buy a PC, if I don't own a PC, so we can directly come to a decision that yes, he should buy a PC. Okay, and now here is own one. Okay, own. Okay, so here at own we will create which is the value is the highest. So here is value is this one, highest, this one, 0.97 model. Okay, so we will check, we will make it the node. Okay, here, so this is the node, and now here we will create how many value it has in that. Let me check it. Let's check it. So in model, latest and old. Okay, and in latest, if latest is there, no value, no decision, and if old is there, yes decision. Okay, we can directly come that to conclusion. Okay, latest, old. So here it will be the value. If the model is latest, he should not buy the PC. Okay, if the model is old, yes, he should buy the PC. Now we have to calculate if someone has rented PC, what decision it will be arrived. So that we have to do it again. We have to calculate for that also. Now I have separated this data from the main data set. Okay, so here is for this, for the rented one, yes and no for the rented one, and model budget all for the rented one. Okay, so here is the rented one, and now we will calculate entropy and information gain for this data set. So let's do it again. So here we will do it again. So entropy of here it will be rented, entropy of the rented. Okay, so total yes in rented is +3, and total no in the rented is -2, and here is 3 which is yes, and 5 minus which is total yes or no calculated, added here. Okay, and we will do and come to here, and now entropy of all the attributes values inside that, and this is here, and now we will get this value, and again this is for age, person age. Okay, person age. Okay, and now we will do it for another data sets, and that is for IG model, for model. Okay, model here. So we have gotten this value, and now we will do it for one more thing, which is budget. Okay, so budget, here we have gotten the value information gain here, and now we will check which information gain is the highest here. So this is budget one. So let's draw the decision tree fully here. We already know that our root node is which one. Okay, so our root node is PC status. Okay, PC status. Okay, this is our root node, and this has 3 values: own, not own, rented. ठीक है, okay. So in not on we already know this value will be yes, he should buy a PC if it does not own a PC, okay. And in own we have already know this. Here it will be a model will be node here, and here it will be latest, and here it will be old. If latest model he have, he should not buy a PC. If he has old model, yes, he should buy a PC. And now in rented there is two value. In budget there is two value, high and low. In high there is all yes, and in low there is no, okay. So here will be node will be budget, high, low. If a high budget will be he should buy a PC, yes, and if the budget is low, no, he should not buy. So we have drawn finally our decision tree. So this is what decision tree is. If somebody come to us and say, should I buy a PC if I have a rented PC and have a low budget? So we will go to here and check. He has a rented PC. PC status is rented and his budget is low. So he should not buy a PC. So this is how we create decision tree. Hopefully you have understand this video. I will see you in my next video. Bye bye. In this video, I will explain you conditional probability with example for machine learning. So let's start this video. So why you should learn conditional probability for machine learning? Because it is the foundation for machine learning. It is the ABC for machine learning. You can't write essay without knowing the basics of English. So probability is the base, and machine learning and supervised learning is built on top of it. So what is probability? Probability is checking the chances of an event happening. Example, what is the chances of head when tossing a coin? So it will be 1 by 2 because we are checking for 1 and 2 is the total chances. So probability of head will be 1 by 2 and probability of tail will be 1 by 2, okay. So what is conditional probability? In conditional probability, we are also checking the chances of an event happening, but on the basis of an event which is already happened. So the condition is that we have to check chances of an event happening on the basis of an event which has already happened. So let's look at the example of conditional probability. So tossing a coin 3 times. So as meaning total samples means total events happening, okay. So here is the total events: 3 times head when we've tossed the coin 3 times, and 2 times head, tail, head, tail, head, and so on 8 times. E, at least 2 tails appear. So here we have to find probability of E. What is the condition here? At least 2 tails appear. So in this event, at least 2 tails will be appeared. So that will be the probability, okay. So where is 2 tails happening? Here not, here not, here not, okay. Here not, here 2 tails happening, here 2 tails happening, here 2 tails, here 2 tails happening, okay. So how many times tails happen? So here is the value 4 and total event 8 because there is the total event 8. So total we get in 1 by 2. So total probability of E is 1 by 2, okay. So this is the example of finding probability, okay. This is the example of probability, okay, right now. Then we will look at conditional probability. So now we have to find F, probability of F, okay. So what if first coin shows head? So first coin shows head. This one is 2, 3, 4. So this is 4, and here we will do it again. 4 by 8 is equal to 1 by 2, okay. So now we have gotten this, and now we have to find conditional probability of these two. We have to find the probability at least 2 tails appear, but the condition is already given, which is F, first coin shows head. The first coin should be ahead. So what is the formula of it? So we have to find probability of E, at least 2 tails appeared, and given is first coin shows head. The first coin will be head, and after that it should be 2 tails, okay. So the formula of it is, so now E intersection F will be there. So this is the sign of intersection. We have to find E intersection F. So what does intersection means? The event which satisfy both, okay. The event that satisfy both. So what it will be? Let's look. So both event is at least 2 tails appeared. So that, okay, and given is first coin shows head. So which one first coin is head, and after that 2 tails. So let's look at here. First coin head and 2 tails. So this is there. So this is the event, and we will write it like this: 1 by 8 because total event is 8, okay. Total event is 8. Chances of it is 8 by PF, probability of F, which we have already find out. So it is 1 by 2, okay. So here it will be 1 by 2. So we get here 2 by 8 and then total value 1 by 4. So this is the probability of this condition. Hopefully you have understand conditional probability, and this was the calculation to calculate that. So thanks for watching this video. Hello everyone, in this video I will teach you what is Ensemble learning and how does it work with examples. So let's start this video. So Ensemble learning. Example, I have to make a decision. Should I buy a new PC? Yes or no? So I will ask with one people, okay? On the basis of his decision, we will buy PC or not, okay? So in machine learning, this is done by one prediction algorithm, but the problem is that we don't get the most accurate answer, okay? Any algorithm, it could be KNN for example, but the problem here is that we don't get the accurate answer, okay? So here come Ensemble learning. So for most accurate decision, we ask for multiple people and then we see which decision is more. So decision should be anything, yes. Some people give yes, yeah, no, anything. And the most common decision will be yes, for example. So we go with it. So Ensemble learning is group of prediction algorithm like KNN, linear logistic regression and more. So they each predict the result and we take their vote and we go with the most voted one. But it requires more computational cost because we are using here multiple algorithm. But when we use one algorithm, the cost is less. But there is no problem because we are getting the most accurate decision, okay? So Ensemble learning is very popular in machine learning because it gives the most accurate decision. It uses multiple learning algorithms to obtain better predictive performance, okay? So here we have our data. So this is the data. This is the data set. According to this data set, we come to the conclusion that should a person buy a PC or not. This is the data of multiple people, okay? For example, Virat own a PC age 36 and he own the latest model and his budget is high. Should he buy a new PC? No. And here we have multiple people data, okay? And here we have that data, okay? And we give it to KNN for example. And it gives us, for example, yes or no, anything. Okay, yes or no, for example, it gives us yes and this gives no, yes, no, okay, yes, no, okay, and we go with one decision. For example, KNN give yes, so we go with yes, okay. But the problem here is that this is simple method and this is weak learning. And if we want strong learning and accurate decision, we go with Ensemble learning. Here we have that data same. So for example, KNN gives us yes, okay. KNN gives us yes, this gives yes, this gives yes, and this gives no, this gives no, okay. So the most common decision here is yes. So here we will combine this all, okay. And we will look at the most common decision. So the most common decision here is yes. So we will go with yes. So this is the most accurate one. So that's why we use Ensemble learning. This is strong learning, okay? And there are types of Ensemble learning. For example, bootstrap aggregating, boosting, stacking, voting, and we will look at each of them in another video, okay? So this is what Ensemble learning is and how does it work, okay? So I will see you in my next video. Hello everyone, in this video I will explain you K-mean clustering with numerical example. So let's start this video. So let's see it with an example so that you can understand it, okay? So here we have to do Instagram user segmentation based on their ranking and followers. We have to put them in a segmentation of A1, for example B1, okay, based on their ranking and followers. So we can create a cluster of K1, which is for example A1, our A1 category, okay. This is a cluster, this is a cluster, okay, and B1 category cluster, okay, which will be K2 cluster, okay. And here we have to put which one goes to which category, okay. So now we have to initialize it, okay. We have to put a value inside it. So a value that could be anything from this. For example, we have to decide A1 category. So what ranking and followers should be in A1 ranking, we have to put it. And another we have to decide B1 category. So which followers ranking and followers count will be in here. And here followers in K, 4K, 8K, okay. So for example, A1 category I will put 10 ranking one and 800K followers, okay. So here we can put randomly here. We have to not calculate it first, and according to that value we will calculate and decide another one that which category they all belong. Okay, so first here we will put R1, which is the value is 10 and 800. Okay, 10 and 800. And here R2, which value is 50 and 400. Okay, 400k followers. So now we need to find out that user ID R3 go and user ID R4, for example, goes to which category, A1 or B1. We have to calculate this by finding out the distance between R1 and then R2. So which will be lowest, in that category it will go. So how we will create the distance, so you will understand once we do it. Okay, so how we will find out distance? We can find out distance very easily by this method. This is Euclidean method. Okay, so here x2 will be user ID. Okay, user ID, and here x1 will be centroid. Okay, the initial value we have defined, that one we have put. Okay, that one. Okay, so we will use this formula and we will calculate the distance. That is really simple, so let's do it. Okay, so let's do it. So first we will do is calculate A1. Okay, A1. So the first value is here 20. Okay, so we will put 20 here. Okay, so let's put 20. 20 minus 10, this value 10. Okay, square. Okay, square plus 700 plus the value of 800. Okay, square, and here square root. Okay, square root is here. Sorry for my drawing. Okay, this is square root. Okay, you can look at here, this is square root, this is square root. Okay, we have to find the square root. So how we will do it? 20 minus 10 will be 10 square plus 700 minus 800, 100 square. So the value will be in almost 100 point is something. Okay, okay, and now we will calculate for B1. Okay, so here B1 is equal to 20 minus 50 square plus 700 minus 400 square, and now the root. Okay, root. So what value we will get? So we will get 20 minus 50, 30 square plus 700 minus 400, 300 squared. Okay, and we have to find the whole root. Okay, you can calculate that. So this value will be near 300 point something. Now we have to see which value is the lowest. 100 is lowest or 300 is lowest. So 100 is lowest. So that means R3 will go to A1 because it is the lowest value. Okay, R3 will go to here because this is the lowest value. And now we have to update the centroid. With this value is, we have to update it. So how we will update it? Let's see. So first we will write here 10 plus the value of here 20. Okay, by 2, and we will calculate the mean of it. So the mean of it will be 30 by 2. So here we will get 15. Okay, and now we have to do it for this centroid value 800 plus the value of here 700. So that will be by 2. So that will be 1500 by 2. So here we will get 750. So now we will update our value. The first value we have get 15 and second one's 750. So here we have to remove this. Okay, so here we have to write 15 and 750 inside this. Okay, and we have to calculate now for each one. Okay, for R4, R5. Okay, and we have to calculate the distance and we have to update the centroid. Okay, so that's it for this video. Hopefully you can do it now. So I will see you in my next video. Hello everyone, in this video I will explain you hierarchical clustering with examples. So let's start this video. So what is clustering? First we have to know that if you don't know already. So clustering Clustering is putting data which is similar to each other into a cluster. Cluster means a category, for example, and the data which is not similar, putting that into another category. So we are putting similar data into a category. For example, this data is similar to each other, so we are putting this into this category, and this data is similar to each other, so we are putting this into this category. So what is example of clustering? Let's suppose Instagram has launched fun program for creators, but the thing is that this is not a great idea to pay each creator the same. So we use clustering to put them into a category. Okay, for example, A1 and B1 category based on their view count. So we have put them into two cluster, one A1 for 100 million plus views and B1 for 10 million to 100 million views. So this is clustering. So what is hierarchical? Hierarchical is attaching the data in order like we do in inheritance, like connecting child with parent and parent with grandfather. Okay, so this is hierarchical. Okay, hierarchical clustering helps to make relationship between clusters. Okay, we can make hierarchical clustering by two ways: agglomerative and divisive. So what is agglomerative? Agglomerative means aggregation. All the data is spread here and there based on their closeness, how similar they are. We combine them in cluster by how similar they are. Okay, this goes from bottom to up, because in bottom there are data points like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we are combining them one by one based on their closeness. So what is divisive? Divisive means division based on point are together. We are dividing them by top down approach like this to this. Okay, and I will show it by making them. Okay, so let's look at agglomerative. Okay, this is the data point down, so 6, 7, 10 and 12. Okay, so here we have to calculate distance between these data points. These are all data points. Okay, data points, and we have to calculate distance between each other, and we will look at which distance is lowest, and then we will make them clusters. Okay, so how we can calculate distance? We can use multiple methods like Euclidean method, but here we are using proximity matrix. Okay, so how does proximity matrix work? So for example, we have 2, 6, 7, 10, 12. By using proximity matrix, we can see that between 10 and 12 there is the distance 2. Okay, and here 6 and 7 the distance is 1. Okay, and between 2 and 6 the distance is 4. So this is proximity matrix. Okay, so same we will do here, and we will create the clusters in a hierarchy order. Okay, so which is the lowest distance here? So 2 to 6 have 4, 6 to 7 has 1, and 7 to 10 has 3, and 10 to 12 has 2. So 6 to 7 we will make it, okay, a cluster like this, and here we will write 6 and 7. Okay, and second one, lowest one is which? So this is the second lowest. Okay, so we will make it 10 and 12. And now which is the third lowest? So now which is lowest? 2, 3, 6, 7, 8, 9, 10. So we can make it like this. Okay, 6, 7, 10, 12. Okay, and now we will look at this 2 to 6. Okay, 2 to 6. So here we can do 2, and here it will be 6, 7. So this is going from down to up. Okay, in a hierarchy. So we have created clusters of hierarchy. Okay, and second method is divisive. So how we use divisive? Let's see. 2, 6, 7. Okay, sorry for this. 10, 12. Okay, and now this is the value, and now we will go from top to bottom like this. Okay, so first which is the lowest? Okay, so we can do like this, and we can do 6, 7, and here we can do like this, 6, 7. Okay, and here we have this value, rest of the value. Okay, now we can go like this, 2, 10, 12. Okay, 10, 12. So this is divisive method, and in this we are going from top to down approach, and in this is agglomerative, and in this we are going from down to up approach. Okay, so this approach is called dendrogram. Like we make line chart like that. Okay, so we can make this in Python using SciPy library. Okay, so that's it for this video. Hopefully you have understand this, and I will see you in my next video.
If you want me to make a video according to your request, or you want me to answer to your questions, you should click on the top link in the description. That will take you to my school community, which is made for people who love machine learning. By doing so, you will support this channel and support me because I am doing this full time. And by joining, you will get exclusive videos, and also you will be getting a video according to your request. Any video you want, I will make that for you. And I will also answer to your every question. So see you inside.